are the important SQL interview questions we will see today. First of all, we should know about join queries. So for the first is, what is the difference between inner join, left join, right join, and full outer join? So a join helps us to uh, keep the rows which match to which that is depending upon a particular column. We decide what rows are matching, and depending upon that, those rows we keep. The whole idea of join is we should be able to derive information from two different tables based on one single column. For a join is nothing but a where clause on a Cartesian product. Cartesian product means we apply we join every row with every other row, and then we apply a where condition on it. Like here, when I say join and I'm performing a join on customer ID, I'm joining every row with every other row and keeping the rows where the customer ID is matched in both the tables, or in both the from both the columns. Inner join helps us to keep only the matches. The left outer join helps to keep every row from the left table and the matches. The right outer join helps us to keep every row from the right table and the matches. The full outer join will keep all the rows from both the sides. Whatever are the columns that are not matching, it will be filled with null. Now, let us see if we have to find out customers who have placed more than 3 orders in a particular column, where we have the customer ID and the number of the orders that they have placed. I do not have the count directly. So now, first of all, I should check by each and every customer how many orders have they placed. So that will be done using group by customer ID. From orders table, group by customer ID. I can derive whatever column we want. This, see, select this part of the query. We can fill it later. Now I only want customers where the count is more than 3. So we aggregate at the customer level, then filter with having. Filter, the main thing here is where will filter rows before group by, having will filter rows after group by. Again, coming to the similar question, the difference between where and having. So it's where, group by, and then having. We should always remember one another thing. What is the sequence in which a query executes? Select is what comes at the last, though we first see select. So in case if there is any joining that is done, then there is where clause, group by, having, and select comes only later. Now, another question is, when can we use a subquery instead of a join? We can use a subquery when the subquery will usually return something like a single value or a filtered set. A join is better when we need columns from both the tables. Like here, one example is select star from employees where salary is more than. I want to see people who are deriving more than the average salary. So where salary is more than, select average salary from employees. So here subquery is better. The next is, what is the CTE and why is it useful? Now CTE is nothing but a temporary table that we get so that we are able to work with it. It helps to improve readability, makes multi-step transformation easier, and it can support recursive queries. So now here I'm making some extra table with monthly sales as I'm performing some query in it, and then I can say select star from monthly sales. So here I am getting a, a table, a short table which has the name monthly sales. And then on that I can apply select, join, filter however I want to. This is more like a multi-step query. Now what are Windows functions and how are they different from group by? In group by, there is one group created uh, that is if there are multiple rows, there is one group created for that, unlike Windows functions. In Windows functions, it will retain all the rows that are there. So like for example, here I say partition by customer ID, sum of amount over partition by customer ID, order by order date. So now consider if I want to get, depending upon the customer ID, want the sum of amount. So now here each and every row will stay visible. I will get 120. Then if it is 180, I will get 300. So I will get a running total for the different customer IDs. So I will get customer ID, order date, and the sum of amount over partition by customer ID. Now, to a very common another question is how to find the second highest salary. Now, for the second highest salary, we can make use of dense rank. Now, we should also check first of all if there are ties, should it return tie or should it just follow the normal order. To get the normal order, it is rank, and to get to ties, it is uh, dense rank. So if ties are important, then dense rank is what we should look for. Dense rank over, and I want result in the overall table. I do not want to partition by anything. So I say over order by salary descending. So whoever is getting the most salary will have this rank 1, whoever is getting the next salary, and so on. And in this, I am making my column as R and K, and here I say where R and K equal to 2. So here, first of all, one mini table will get created, which will have this employee ID, salary, and the rank. And then after that, I will select only the employee ID and the salary where the rank is 2. How would you remove duplicate rows while keeping the latest row? Consider these are the rows which are updated. This got updated at 10 o'clock. This I got updated at 11:30. And I want to keep only this one. I do not want to keep this one. So here what I can do is that is I will decide the row number over partition by customer ID, product ID, order by updated and descending. So now this order by updated at. So that means this is my updated at column descending. So and then after this, so here I will get the row number. For this I will get 1. For this also I will get 1. For this one I will get 2. And then I can run my delete query where the row number is not equal to 1. So I can define what makes a row duplicate and then rank rows and then delete rows where the row number is not 1. So for each and every SQL query, what is very important is to decide one strategy. How can this be solved step by step? And then we go ahead solving those steps. How can we calculate month over month growth? A very, very important question again. So now here I will calculate month over month. I will have uh, current month minus the prior month. So that is my new sale value divided by the prior month. So that is indicating growth. So aggregate to month first and then use lag to compare the current month to the previous month. So here lag function is what will help me. And then after that because in the denominator I might get 0, and so I protect the denominator from 0 or null. So this month over month growth is also very important. When should we use case when? We should use case when we want to categorize the data depending upon certain buckets, or we want to bin the data. Bin the data as in 10 to 50 one value, 50 to 100 one value, more than 100 one value. So in all these cases, we go for case when. Null in SQL. What is null in SQL and how when can it cause surprising results? So null basically means unknown or missing. It does not mean 0. 0 is different from null, and it does not even mean an empty string. So comparison with null uses three valued logic. Equal to null is not does not work. We can only say is null or not. And if we say count, if we say count column, it will ignore the null that is there. But if I say count star, it will count the number of rows that are there. So if I say for this particular column count star, it will give me 3. But if I say count column name, then it will give me 2, because this one is unknown. What is an index and how can it improve query performance? An index is nothing but it's some kind of a data structure that helps us to find out where the database rows are without scanning the entire table. Now consider a book index. There we have some content topics, and I can go to those content topics. Similarly, if I can store about the primary key and with the location of those rows where the primary key values are there, then it will help me. So it helps us to improve selecting filters, joins, and some order by operations. I can create index on particular column of the table. Now, in case if an SQL query is slow, I will try to understand the query plan. I will try to understand the join cardinality. Now, join cardinality indicates that how many records are getting joined with the other records. Let's say if there is a where, I can apply the where clause before joining or after joining also. Let's say where designation equal to engineer. So now this can be applied before joining and after joining. Now what happens if I apply it before joining? If I apply it before joining, then in that case it will reduce the number of joins. So join cardinality is also very important. What filters, what indexes are being used, and what is the sorting and the aggregation cost. So like this, if we jot down a clear plan, it will help us to optimize the SQL query. What is database normalization? Not everything can be stored together in one table, and so we go for database normalization, where we split that big large table into several tables, keeping one column in common, and also we avoid insert, update, and deletion anomalies. Like here, customers will be there in one table, orders will be maintained in another table, products will be maintained in another table. Normalization is basically to reduce redundancy. Redundancy generally means repetition. How would you calculate each product's percentage of total sales? So to calculate how much has this particular product helped me, I can do. So first of all, we calculate product level sales and then divide by the grand total. So a window sum can help us to do this. This is a very intricate query. That is, we have to calculate what is the sum of sales of this particular product divided by sum of sales over as in using a Windows function. You can go through more about this in details. These are the most probable questions that can be asked. The difference between union and union all. So in case if I have to perform, if I have ABC and CDE, union will give me ABCDE. Union all will also retain the duplicates and it will give me ABCCDE. How would you identify customers who did not place an order in the last 90 days? Now here first of all I will calculate order date and the current date, and I want the interval as 90 days. And then wherever join, and then if I see that the interval has to be less than 90 days, otherwise it will not be taken. So these are certain probable questions. For reading more about these, you can query further, but these are the overall probable questions.